Okay, in this video, the learning target is I can graph a quadratic in intercept form to solve an application problem. Now, if you remember, intercept form is when we have y equals a times x minus p times x minus q, and then the opposites of our p and q values tell us where we're at as our x-intercepts. They tell us where we're at on our x-axis. Okay, so the opposites of both of those give us our x-intercepts. So if we look at number one here, it says Mario and Yoshi are attempting to make a jump to another landing. Okay, so we have Mario here. He's got to try and make this jump across the gap and land on top of the second platform. Okay, Yoshi's jump can be modeled by this equation. Y equals negative 0.02x times x minus 50, where y is the height in feet and x is the horizontal distance in feet. We're going to make a rough sketch of the graph of the function, and we're going to try and figure out, will Mario and Yoshi make it? Why or why not? And then we're also going to try and figure out how far can Yoshi jump. So to start with the graph, looking at this equation, you'll notice that I have an x by itself. Okay, remember that when you have an x by itself, that's really the same thing as saying x minus 0 times x minus 50. Okay, this x by itself is really the same thing as x minus 0. We just don't write the minus 0 because when you subtract 0, x minus 0 is just simply x. So the x by itself gives us an x-intercept at 0. And then the x minus 50 gives us an x-intercept at 50. Okay, so we have an x-intercept at 0 and an x-intercept at 50. And then if I want to find the vertex on my parabola, remember parabolas are symmetrical, right? So if these are the two x-intercepts, I know the vertex has to fall directly in the middle between the two. So the axis of symmetry, the number between 0 and 50, would be 25. So my vertex has to fall when x is 25. So what I can do is I can actually plug 25 into the function to figure out how high I am on this line, like how high the vertex falls on this line, I should say. So once again, I'm going to take this value and I'm just going to plug it into the function. So I'm going to get negative 0.02 times 25 times 25 minus 50. Now, what I can do is I can simply just plug this into my calculator and it will tell me how high the jump goes on the axis of symmetry. So on my calculator here, I'm just going to type in that information. Okay. So when I do that, I'm taking negative 0.02 times 25 times 25 minus 50. Okay, plug it in exactly how it's written with the parentheses and everything. If you hit enter, it'll tell you 12.5 feet. Okay, so 12.5. So on my graph here, I'm going to draw a little line. I'm going to write 12.5, and I'm going to put a point on the axis of symmetry there. And then maybe I'll label that too. So that's 25 on the x, and it's going to be 12.5 on the y. And then I'm just going to draw my parabola through those points. Okay, so looking at my graph here and looking at the picture, I want to determine if Mario and Yoshi will make their jump. Well, if I look at the photo, notice that they have to jump 25 feet across and they have to go 25 or 10 feet up. Okay, so 25 feet across, 10 feet up. Well, if I look at my image, their jump, Yoshi's jumping ability, goes 25 feet across and it has a height of 12.5 feet. So because 12.5 feet is bigger than 10 feet and they're going the same distance across, I'm going to say yes, they will make it. And the reason why is because at 25 feet of horizontal distance, okay, so at 25 feet of horizontal distance, they will be at a height of 12.5 feet. Okay, so yes, because at 25 feet, they're at a height of 12 feet, which clears 10 feet. Okay, if you wanted to shorten this up, you could say at 25 feet across, they're at 12.5 feet high, which is bigger than 10 feet. So that would get the same point across as well. And then it says, how far can Yoshi jump? Well, if you look at the picture of my graph, he started at 0, he landed at 50, so he can jump 50 feet out. Okay, so how far he can go is 50 feet. Okay, so let's go ahead and look at a second example then. So number 2 says, you hit a golf ball, and the path of the ball can be modeled by this equation, where y is the height of the ball in yards and x is the horizontal distance in yards. We need to graph the functions. So you'll notice they give us the graph. We just kind of need to label the important pieces and then figure out what is the maximum height of the ball and how far did the ball travel. So once again, remember when you have an x by itself, that's telling you there's an x-intercept at 0. So we have an x-intercept at 0. And then the negative 120 puts an x-intercept at 120. Okay, those are the zeros of my function. And then in between 0 and 120, I have the axis of symmetry in the middle, right? And the axis of symmetry is going to be at 60. And then if I want to find the vertex, how high I am at 60, I simply just plug 60 in for the x's, right? This is an x value because it's on the x-axis. So I plug 60 in, so I get negative 0.18 times 60, and then 60 minus 120. And once again, I can just simply type all of this into the calculator, and it will give me the height. So if I go ahead and do that, I'm taking negative 0.18 times 60 times 60 minus 120, and I get 648. 648. Okay, so on my graph, this height here, and it's obviously it's not drawn to scale, but this would be 648. And so this point is 60 on my x and 648 on the y. Okay. And now we're ready to answer some questions. So when it says what is the maximum height of the ball, well, I just see how high did the ball go? Well, that's just where the vertex is, the height of the vertex, which is 648. So 648 yards. And then it says, how far does the ball travel? Well, it went 0 to 120, so that'd be 120 yards.